Today we're going to start section 10.3, which is how we use parametric equations in calculus. And so we're going to start off with a theorem that involves the derivative. If a smooth curve C is given by the equations x equals f of t and y equals g of t, so x and y have parametric equations, then the slope of C at the point xy is dy dx, which is dy dt over dx dt. If you think about that, if you just divide those two fractions, they would simplify back to dy dx, so it's mathematically true. And all we're really saying is the derivative, excuse me, the derivative of y with respect to t would be y prime, y prime of t, and the derivative with x with respect to t would be x prime of t, if it's easier to think of it like that. And you do just have to, make sure x prime of t can't be 0 in that situation, so you're not dividing by 0. And since we can find the first derivative, since that's a function of t, then we can use this theorem to find other derivatives, higher order derivatives. You'll usually just be asked to find the second order derivative. I can't think of having to go higher than that, but we could. So how do we do that? Let's write what it's not first. Unfortunately, the second derivative is not just the second derivative of y over the second derivative of x. I'm going to kind of show why that's true here. So when we have the second derivative of y with respect to x, let's just rewrite that how we're kind of used to writing that. The derivative with respect to x of the first derivative, dy dx. That's how we get that d squared y over dx squared. Now, we just said in the previous theorem that dy dx with respect to t will be, so let me write this, d dx. It will be dy dt over dx dt, since we're working with parametric equations. And I can do a little bit of fancy math here, because this derivative with respect to x, it doesn't get like multiplied into the numerator and the denominator. So that's why it's not just like the second derivative of y over the second derivative of x. But we can kind of swap some things. So if I'm multiplying these two fractions together, if I swap these denominators, make it d dt on the outside, then you can see I have dy dx over dx dt. So all I did was switch these two, right? That still multiplies out to the same thing if you did that. And so this is saying take the derivative with respect to t of the first derivative, dy dx, so your answer to the first derivative, and divide it by, I'm just going to make this x prime of t, divided by x prime of t. It's that little divided by x prime of t part that we tend to forget, so we have to be careful with that. So again, it's in words, it's the derivative of dy dx, that answer, in terms of t, or I'll just write in terms of t, because dy dx will be an answer that involves t, divided by x prime of t. So let's use that formula to do these examples. So find dy dx and the second derivative for the curve given by x equals sine t and y equals cosine t. So dy dx, I like to write is equal to y prime of t over x prime of t. That's not required for the AP test. It just kind of helps me organize things. So the derivative of y is negative sine t, and the derivative of x is cosine t. And since I'm going to be finding the second derivative, I don't want to have a fraction here. I'd rather simplify this to make it negative tangent t, so I don't have any like little quotient rules or anything to do. So the first derivative, I'm just going to rewrite this so I can call it an answer. The first derivative is negative tangent of t. And then the second derivative is equal to, I think it helps to write this out when you're first starting, the derivative of t, derivative with respect to t, excuse me, of your answer, dy dx. So negative tangent t I like to kind of write this out first before just taking that derivative, over x prime of t, so over cosine of t. That was the answer to x prime of t. All right, and then the derivative of negative tangent is negative secant squared of t over cosine t. And you could simplify this either as negative secant cubed of t, that's what I would do, or you could switch it to like negative 1 over cosine to the third of t. It doesn't matter. It's just kind of either looking for an answer in multiple choice, or in number 2, we're going to be using an answer like that to get concavity. So however, it's easier for you to find critical numbers or possible inflection points. All right, so number 2 says find the slope and concavity at the point 2, 3 for the curve given by x equals and y equals. And t greater than or equal to 0 just tells us that x is going to be a real number. All right, so to start off with slope, slope would be dy dx. So remember, that's y prime over x prime. Y prime, let's see, 1/4 of t squared would be 2t over 4 when I take the derivative, so t over 2. And then you'll have a constant, right? 1/4 times 4, the derivative of that will be 0, over x prime. So this would be 1/2 t to the negative 1/2. So we should definitely clean this up. We have 1/2 over 1/2, so those cancel. And then t to the first over t to the 1 to the negative 1/2 is t to the 3 halves. So I need to find the slope at the point 2, 3. That's an x, y coordinate, but our derivative is in terms of t. So to figure that out, I have to figure out what t is equal to. When you're finding t, you should plug each component into both equations, because sometimes if the equations have multiple answers, you're looking for whatever answer they have in common. So x equals square root of t, x is 2, so 2 equals square root of t. Here I only get one answer, square both sides, t equals 4. So I do know that I'm going to be finding the slope at 4, but just to show you that you should be checking both, 3 equals 1/4 times t squared minus 4. So if you multiply 4 over here, you get 12. Add 4, you get 16 equals t squared. So here I get plus or minus 4 equals t. Now they did tell us in the problem that t is greater than or equal to 0, so that eliminates the minus 4 option, but also t has to satisfy both components. So it has to be t equals 4 to help me figure out where we're actually hitting the point 2, 3. All right, so the slope dy dx evaluated at t equals 4 is 4 to the 3 halves. Square root of 4 is 2. 2 to the third is 8. So the slope is 8. For concavity, we need to find the second derivative. And now I might not show this in my homework every time. I was trying to, but the key I was making kept crashing. So I have an old key up where I get straight to just taking the derivative of my answer, but I think it's smarter to show yourself this. You need to take the derivative with respect to t of the answer you got for dy dx, and then divide it by x prime of t. So you could either write x prime of t right here, or you could get right to showing what x prime of t was, 1/2 t to the negative 1/2. Doesn't really matter. So if I take the derivative of this, I get 3 over 2 t to the positive 1/2. And remember, x prime of t was 1/2 t to the negative 1/2. 3 halves divided by 1/2. The 2's are going to cancel, so you're going to get 3. These exponents add up to 1, so 3t. And then again, we already know, we don't have to solve for t again. We know that at the point 2, 3, t is equal to 4. So we want to know what's the concavity at t equals 4, so that, or what's the sign of the second derivative, excuse me, at t equals 4, so that we can figure out the concavity. So the second derivative of y with respect to x is equal to evaluated at t equals 4 is equal to 3 times 4, which is 12. All we really care about is that that's greater than 0. So I can say that this curve, I'm not going to write out the equations, but I'm going to say the curve is concave up at the point 2, 3. All right, next example. Find the first and second derivative for the curve given by these two equations. Okay, so let's just start off. dy dx is y prime over t over x prime of t. I didn't mean over t, sorry. So the derivative of y is 9t squared plus 6. And the derivative of x is 2t minus 2. And maybe we want to factor this a little bit. I don't know. 3t plus 2. We're going to be taking the derivative of it again with some quotient rules. So I don't know. Maybe that'll help. All right. So this is the first derivative. That's my answer to that. The second derivative, this ought to be fun. It's the derivative of that answer I just got. So I'm going to write it as 3 over 2 times 3t plus 2 over, t minus 1. So I think I am going to leave it factored out. You don't have to do it that way. I don't know what will be easier. And then don't forget, though, it's over that x prime. So it's over 2t minus 2, or it's over 2 times t minus 1. All right, so we have to remember how to do quotient rule, right? There's a constant out in front. So I'm going to say 3 over 2 times something. And then I'm going to also put, so I don't forget about this, over 2 times t minus 1. All right, so remember it's low d high. So t minus 1 low, the derivative of the top is just 3 minus high d low, the derivative of the bottom is 1 over low, t minus 1, the quantity squared. That's not so bad. I'm kind of running out of room. Instead of 3 over 2 over 2, how about we make that 3 over 4? And then we have, you know what, just for room's sake, 3/4 times. Okay, and then what do I have here? Instead of t minus 1 squared over t minus 1, why don't we put in the denominator? That's a total of t minus 1 to the third. And then, oh my goodness, I'm going to erase this just for my, so I have room. So remind myself that I had this. Okay. And then what do I have up here? I have 3t minus 3, distribute a negative through, minus 3t minus 2. That cleans up pretty nicely. So 3 times negative 5 is negative 15 over 4 times the quantity t minus 1 cubed. So that's our second derivative. All right, and then follow up with that. Find the point, xy point is always what that means, when the curve has a vertical tangent line. When will the curve have a vertical tangent line? Well, that's when we're dealing with the first derivative, when the first derivative is undefined. So when dy dx is undefined, that happens when the denominator, t minus 1, well, t minus 1 equals 0. I got right to it, didn't I? So when t equals 1, find the point where that happens. Well, I know that it happens when t equals 1. And if I want to find the points, I have equations for x and for y. So x is equal to t squared, 1, minus 2 times t, minus 2, plus 1. So x is 0. Y is equal to 3 times t to the third. So 3 plus 6 times t, so plus 6. Y is equal to 9. So there is a vertical tangent at 0, 9. You can kind of, in parametric mode, you can check these, although checking can get confusing, I think, because like you have to adjust the window a lot, and sometimes if you just do zoom 6, their step size, I think by default, is like 7.5, when we really might want it to be 1 or 0.1. They start t at 0, you might want it to be negative. So anyway, I tend not to check these on my calculator and just trust my math, because the calculator tends to make me second guess things. Okay, on to the next example. So a particle travels on a curve given by x of t and y of t. Find the ordered pair, the xy, for the system when t equals pi over 4. So this is simply asking what's the xy, like we did in the last part of the final answer. This is just saying find x of pi over 4 and find y of pi over 4. When you plug pi over 4 in, though, it's 3 times that angle. So we're really saying what's the cosine of 3 pi over 4? I know cosine of pi over 4 is radical 2 over 2, but we're in quadrant 2. So negative radical 2 over 2. And y of pi over 4? It's 2 times the sine of 3 pi over 4. Now sine in quadrant 2 is positive. So 2 times radical 2 over 2 is just radical 2. So the ordered pair is negative radical 2 over 2 and radical 2. Find the equation of the line tangent to the curve at t equals pi over 4. So we need a point to write an equation for a tangent line, which we have. We need a slope, so we need to know dy dx, and we'll have to evaluate it at t equals pi over 4. Okay, so dy dx, 2 times cosine of 3t, don't forget about the chain rule, times 3, because you have that 3t there. So really 6 cosine of 3t is on top. For x, same idea, you're going to get negative sine of 3t, but don't forget to multiply that by 3. So negative 3 sine of 3t, and we might as well simplify this to negative 2, and then cosine over sine is cotangent of 3t. Now you don't have to do that. You just need to be able to plug in pi over 4. So it depends on how well you remember your unit circle values, basically. So when I don't want to say equals, when I evaluate dy dx at t equals pi over 4, negative 2 times the cotangent of 3 pi over 4. Remember, pi over 4 is easy for tangent and cotangent. It's either 1 or negative 1, so you're in quadrant 2. Cotangent's negative in quadrant 2. So negative 2 times negative 1 is positive 2. So the slope is 2. The point is from the previous problem. The equation for the tangent line in point slope form is y minus radical 2 equals 2 times x plus radical 2 over 2. Find the second derivative and determine the concavity at t equals pi over 4. All right, so the second derivative, remember, the second derivative is the derivative with respect to t of the answer you got from the first derivative, negative 2 cotangent of 3t. And don't forget to divide it by x prime. X prime was negative 3 sine of 3t. Let's see, remember the derivative of the trig functions that start with c, those are negative. So I'm going to have a positive value, and chain rule is going to put a 3 out here. So I'm going to have a positive 6. And then the derivative of cotangent is, I already took care of the negative, so I'm just going to have cosecant squared of 3t divided by that x of t, x prime of t, I mean. That simplifies. 6 divided by negative 3 is negative 2. And I think I'll just make it cosecant to the third of 3t. You can make it negative 2 over sine to the third. It doesn't matter. Evaluating at pi over 4, so the second derivative at t equals pi over 4 is equal to negative 2 times what? We've got cosecant of 3 pi over 4. So cosecant's positive in quadrant 2. And we know sine is radical 2 over 2, but remember the simplified reciprocal of that is just radical 2. So this will be radical 2 positive to the third power. Well, radical 2 to the third power is 2 radical 2, right? So negative 2 times 2 radical 2. And that's just equal to negative 4 radical 2. So since that's coming out less than 0, I can say concave down at t equals 4, pi over 4. At t equals pi over 4, is the particle moving left or right, up or down? So is the particle moving to the left or to the right? We had this back in the beginning of the year. Remember, this is based off of, in the beginning of the year, it was based off of velocity. So we just want to say, well, left or right is based off of x prime. So what is the value of x prime at pi over 4? So not the whole derivative put together, but just x prime itself. So that was negative 3 times the sine of 3 pi over 4. It doesn't really matter what the numerical value is. It's a negative times a positive. I mean, you can find it. It's negative 3 times radical 2 over 2. But that's less than 0, so the particle is moving left. And then find y prime of pi over 4. Y prime, which is the numerator there, 6 times the cosine of 3 pi over 4. So that's positive 6 times, cosine is negative in quadrant 2, so that's a positive times a negative is less than 0, so moving down. All right, now the rest of this is going to be homework. You're just practicing with another set of equations. And you can check my answer key if you're getting confused on horizontal and tangent and vertical tangents. But remember, horizontal tangents are just when dy dx equals 0, if that is possible. And vertical is when dy dx is undefined. So basically, horizontal is when the numerator equals 0, and vertical is when the denominator equals 0. It could be that you don't have a horizontal or a vertical tangent. Since it says find all points, you're going to be finding the value of t when that happens, but you need to go back and figure out what x, y corresponds to that value of t. All right, and then we do have, oh no, there's not an AP problem. So yeah, you're finishing this for homework, and then we also have number 30 for homework as well.